When we picture a planet, we instinctively think of stability. We think of Earth, a solid, spherical rock that has endured for 4.5 billion years. We think of Jupiter, a gas giant so massive and permanent that it acts as the anchor of our solar system. In our minds, planets are the safe harbors of the universe. They are the survivors. They are the rigid stages upon which the drama of geology and biology plays out. We assume that once a planet forms, it is there to stay, orbiting its star in a silent, eternal waltz until the star itself dies. But the universe is not always so kind. And it is certainly not always so stable. Recent discoveries by NASA's planet-hunting telescopes have revealed a terrifying class of worlds that defy this definition. These are not safe harbors. They are victims. They are worlds that have wandered too close to the fires of their parent stars and are paying the ultimate price. Astronomers have found planets that are not spherical, but are being stretched and torn apart. They have found worlds that are not growing, but shrinking. We have found a planet that is literally bleeding into space. Before we journey to this violent frontier to witness the slow death of a world, if you enjoy exploring the most extreme and mysterious corners of the cosmos, please take a moment to subscribe to the channel and hit the like button. It supports our mission to map the universe, one video at a time. To understand this tragedy, we must first look at the tool that revealed it to us. For the last few years, a spacecraft called TESS, the Transiting Exoplanet Survey Satellite, has been scanning the sky, staring at millions of stars. Its method is simple but brilliant. It waits for a planet to pass in front of its star. When a planet crosses the face of a star, it blocks a tiny fraction of the light. If you were to plot this on a graph, you would see a dip. For a normal, spherical planet like Earth or Jupiter, this dip is symmetrical. It looks like a U shape. The light drops as the planet enters, stays flat as the planet crosses, and rises back up quickly as the planet exits. It is a clean, sharp shadow. But recently, astronomers noticed a signal that looked wrong. In the data from a system roughly 1,000 light-years away, the light didn't just dip and return. It crashed down, and then, instead of snapping back up, it dragged. It lingered. The graph didn't look like a U. It looked like a sawtooth. It looked like a smear. This asymmetry told the scientists something profound. Whatever was blocking the star's light was not a clean sphere. It was messy. It was a chaotic cloud of debris trailing behind the planet for millions of kilometers. This wasn't the first time we had seen such a thing. Back in the days of the Kepler mission, we found a mysterious object named K2-22b. At the time, it was an anomaly. A ghost in the data. But TESS has confirmed that this is not a glitch. It is a category. They realized they weren't looking at a planet in the traditional sense. They were looking at a disintegrating ultra-short period planet. Or, to put it in more poetic terms, a planet that has turned into a comet. Let's travel there and visualize what this world looks like. Imagine a planet roughly the size of Mars or Mercury. But unlike our rusty neighbors, this world is not cold. It orbits its star at a distance that makes Mercury look like it is in a deep freeze. It completes an entire year, a full orbit, in less than 16 hours. It is so close that it is tidally locked, meaning one side faces the star forever, while the other is frozen in eternal night. On the day side, the temperature soars to over 2,000 degrees Celsius. This is hot enough to melt iron. It is hot enough to vaporize rock. The surface of this world is likely a global ocean of magma, bubbling and churning under the glare of a sun that fills the entire sky. But the heat is only the beginning of the problem. The real killer is the gravity and the radiation. At this proximity, the star is blasting the planet with a relentless wind of high-energy X-rays and UV radiation. On Earth, our atmosphere protects us. But on this world, the radiation is so intense that it imparts energy to the gas atoms in the atmosphere, heating them up until they move fast enough to escape the planet's gravity. This is a process called hydrodynamic escape. The planet is essentially boiling away. But it gets more violent. The atmosphere isn't just vanishing into the void. The rock itself is vaporizing. Silicates, iron, aluminum, the very stuff the planet is made of, are turning into gas. This mineral vapor rises into the sky, where it condenses into tiny grains of dust. And this is where the bleeding begins. Because the planet is moving so fast in its orbit, traveling at hundreds of kilometers per second, and because the pressure from the star's light, radiation pressure, is pushing against this cloud of dust, the material is swept backward. It forms a massive, glowing tail behind the planet. If you could float in space and watch this world pass by, it wouldn't look like a round marble. It would look like a titanic comet. A head of molten rock, glowing a dull, angry red, trailed by a long, curved stream of dust and gas that stretches for tens of millions of kilometers. The light from the star would filter through this tail, scattering in hues of orange and red, painting a picture of absolute destruction. This is the tail that TESS saw. When the planet passed in front of the star, the main body blocked the light first, causing the sharp dip. But long after the planet had passed, the tail was still crossing the face of the star, slowly blocking the light, causing that long, lingering drag in the data. We are watching a world being flayed alive. This phenomenon forces us to confront a concept in astrophysics known as the Roche limit. The Roche limit is the invisible line of death around a massive object. If a moon or a planet gets closer than this line, the tidal forces, the difference in gravity pulling on the front of the planet versus the back, become stronger than the gravity holding the planet together. When a world crosses the Roche limit, it is torn apart. It crumbles. The planets we are observing, like K2-22b or the one in the BD plus 4868 system, are dancing right on the edge of this cliff. They haven't been fully ripped apart yet, but they are losing the battle. They are shedding mass at a rate of millions of tons per second. In our own solar system, we see a miniature version of this. We see sun-grazing comets, balls of ice and dust that dive too close to the sun and evaporate. But here, we are talking about an entire rocky world. A place with a core, a mantle, and perhaps once, a geological history. This raises a fascinating question. What is the fate of such a world? It is a slow, agonizing death. Over millions of years, the planet will continue to shrink. First, it loses its atmosphere. Then, it loses its crust. The magma ocean boils away into space, joining the tail. Eventually, all that might remain is the dense, iron-rich core, a stripped planetary ember known as a Chthonian planet. Or, perhaps, even the core will not survive. The planet might disintegrate completely, leaving nothing but a ring of dust around the star, a tombstone made of its own remains. Astronomers speculate that some of the dust rings we see around other stars might actually be the ghosts of dead planets. This discovery changes how we view our own solar system. We look at Mercury, scorched by the sun, and we think it has it rough. But Mercury is safe. It is stable. These bleeding planets show us that planetary systems are dynamic, violent, and constantly evolving places. It is possible that in the distant past of our own solar system, or perhaps in its chaotic future billions of years from now, worlds have met or will meet similar fates. It reminds us that being a planet is not a permanent status. It is a temporary state of equilibrium in a universe that tends toward chaos. We are currently witnessing a snapshot of a murder in progress. The star is consuming its child. And thanks to instruments like TESS and the upcoming Plato mission, we are able to capture the evidence before the victim vanishes entirely. It is a grim, yet beautiful reminder of the power of physics. These bleeding worlds, with their tales of vaporized rock and iron, are painting the galaxy with the story of their own destruction. They are the most dramatic fireworks in the cosmos, burning themselves out to show us the limits of survival. Thank you for joining me on this journey to the edge of destruction. If you found this story fascinating, let me know in the comments. Do you think our solar system ever had a planet that met this fate? And don't forget to subscribe and click the bell icon so you're notified of our next deep dive into the universe. Till next time, keep looking up.